Today, I'll guide you through using the Geometry Proximity node in Blender to create an interactive animation where blocks respond to each other via an empty object. This technique makes your blocks react to the empty's position like a lively tile floor. Let's get started. First, select a cube in your scene. Then, switch to the Geometry Node Editor workspace by selecting the Geometry Nodes tab at the bottom of the screen. Now, click the New button to add a new geometry tree. Next, disconnect the link between Group Input and Group Output, as we'll build from scratch. Next, add a grid node. Connect the grid's output directly to the geometry input of the group output. At this point, you have a basic plane. Adjust the grid node's parameters. Set size x and y to 10 and vertices x and y to 10, creating a 10 by 10 grid with a larger size. Now, add a Mesh to Points node. Connect the mesh output from the grid to the mesh input of Mesh to Points, then connect its points output to the group output. The plane is now converted to points, ready for instancing later. Create a new small cube by adding a cube. Select this cube, scale it slightly along the z-axis to flatten it a bit. Then apply a bevel to the four corners. Just press Ctrl B for a gentle round, giving it a softer look. Now, drag the new cube into the Geometry Node Editor area, so Blender automatically creates an Object Info node for it. Next, add an Instance on Points node. Connect the points output from Mesh to Points to the points input of Instance on Points. Then add the Object Info for the cube, and connect its output to the Instance input of Instance on Points. Now, the small cubes will distribute evenly across the points. Adjust the scale and instance on points so the cubes fit nicely on the grid. For interaction, add an empty. Select the empty, then drag it into the Geometry Node Editor to create an Object Info node for it. Add a Mesh Line node and connect the empty Object Info's output to the start input of Mesh Line. Then, connect the mesh output of Mesh Line to the target input of a Geometry Proximity node. Next, add a Set Position node. Connect the instance's output from Instance on Points to the geometry input of Set Position, then connect Set Position's output to the group output. To control positions, add a Combine XYZ node and connect its vector output to the position input of Set Position. Now add a Map Range node. Connect the distance output from Geometry Proximity to the value input of Map Range, then connect Map Range's result output to the Z input of Combine XYZ. That's the basics done. You can now control the cube's positions by moving the empty. The cubes near it will push up along the z-axis based on distance. Adjust the map range parameters for the position changes you want. It seems the initial cube positions are still slightly off. Fix it by connecting the location socket from the empty object info directly to the start location socket of the mesh line. Now, the line starts from the empty's position, making proximity more accurate and stabilizing the initial setup. To expand the cube area into a wider tile floor, add a Transform Geometry node. Connect the instance's output from Instance on Points to the geometry input of the first transform geometry. Change the location of the Transform Geometry nodes, for example, to form a wider cube region like a tile base. Great. Now we have a larger cube field. Next, add a sphere as the main interactive element. To make it look better, add materials. Create a new material for the cube. Back in Geometry Nodes, add a Set Material node. Place it right before the group output and assign the cube material to its material input. For some lighting, add a point light. Now it's almost done. Select sphere, then shift select the empty, press Ctrl P, A, and choose object to parent the sphere to the empty. Now the empty controls the sphere. Similarly, select the light, shift select the empty, Ctrl P, and choose object to parent the light to the empty. Back to frame 0, select the empty, keyframe its location. Move the empty to your desired position at frame 250 and keyframe it. Select the sphere, go to frame 0, set rotate Y to 0 and insert a keyframe. Then go to frame 250, set rotate Y to nidus and 720 and keyframe it again. Play back to see the sphere rotate smoothly. That's it. Good luck with your Blender project. If you have any questions, just ask.